Welcome to Study Loop.
So we are given q as a function of time in this form. And q is equal to a e to the minus r over 2l times t times cos omega prime t plus phi, where omega prime is the angular frequency of the damped oscillations. So the first thing we will do is we'll calculate the first derivative of q with respect to time. So from above, dq dt is equal to minus a times r over 2l times e to the minus r over 2l multiplied by t, all times cos of omega prime t plus phi minus omega prime times a e to the minus r over 2l times t times sine omega prime t plus phi. So we have a long expression for dq dt. And then we need to find the second derivative with respect to time, d2q dt squared, by finding the derivative of this expression with respect to t. And so this is a into r over 2l all squared e to the minus r over 2l times t times cos omega prime t plus phi plus 2 omega prime times a r over 2l e to the minus r over 2l times t times sine omega prime t plus phi minus omega prime squared times a e to the minus r over 2l times t times cos omega prime times t plus phi. And hence we have an extremely long expression for the second derivative of q with respect to time. So if we can put these values back into our differential equation, our differential equation is d2q dt squared plus r over l dq dt plus q over l c. We substitute our values from above for the derivatives. We get that this is q into r over 2l all squared minus omega prime squared minus r squared over 2l squared plus 1 over l c. And all this is equal to 0, provided that omega prime squared is equal to 1 over lc minus r squared over 4 l squared. So this is the form of the angular frequency of the damped oscillations as we know it, and hence we satisfy our differential equation. Next, for part B, we are told that at time equal to 0, q is equal equal to capital Q, and the current I is equal to dq dt is 0. And so we can see from here that Q becomes A cos phi, and this is equal to capital Q. And from our expression above, the rate of change dq dt when t is equal to 0 becomes minus r over 2l times A cos phi minus omega prime times A sin phi, and this is equal to 0. So from here, we can see firstly that A is equal to Q over cos phi. And secondly, if we divide this expression for dq dt through by cos phi, we get that tan phi is equal to minus r over 2l omega prime. And this is simply minus r all over 2l times the square root, substituting for omega prime here, 1 over l times c minus r squared over 4l squared as required.